Okay, so there's Mawson. Okay, since everybody's in here, I want to take just a minute to talk about our schedule now coming up for the next couple of weeks. Next week, we have class all three of our days again next week. We'll have class this Friday as well. But what's important next week is Wednesday, April 6th, is going to be test 3. Sorry, unit 3 test. This is the big one. This is really the important unit of the course. I'm sure you've noticed we've slowed down and we're doing more examples and taking our time on it because this is the stuff that I feel really matters out of the class. After that, then it looks like the following week, some of you are out on spring break. We'll have class on April 11th. April 11th, there will be class. But April 13th, we will not. And then, of course, April 15th is Good Friday. There'll be no class on those 2 days because Clayton is on spring break that whole week. We'll only do one class during that week. And then Mauston, you guys are out on the 18th, and I think one of the other schools was as well. April 18th is also no class. We'll come back and well, for right now, we're leaving April 18th as a potential. We might have class to catch up, but right now it's a no class situation. Then that should put us on pace to finish up then after for the rest of the year if we don't have any more days off, which it doesn't look like. There might be one day that one school is out for the rest of the year, but that should put us on pace. So the big thing to be ready for is next week, Wednesday, April 6th, with our Unit 3 test. And of course, we'll keep you posted on the scheduling more as we get closer to that week of April 11th. Excuse me. So we had mentioned at the end of class on Monday, dosages based on weight. And we used it simply to demonstrate how that idea of a titration worked, where we can change a single parameter of our calculation, and we can change our answer without having to redo the whole calculation. It's a very handy tool. Well, today we're going to look at actually how the weight is used to calculate dosage. And so we're going to look at an example where the doctor gives us an order. And the order is just going to be to administer the recommended dose. So I'm just going to use REC to abbreviate recommendation here again. So the recommendation is 1820 micrograms per kilogram per hour. And on the label, it tells us that the medication is constituted of 25 milligrams in 4 milliliters of fluid. Now we still need to know something about our patient here because it is dosage based on weight. We need to know the patient's weight. So our patient here has a weight of 143 pounds. So the first thing we'll notice here is our recommendation is given in an amount per kilogram. Our patient's weight is given in pounds. So to rectify that, we have to convert the pounds into kilograms. Now we saw this a little bit in the last couple of classes. Converting pounds into kilograms is something we do often enough that we're not going to go through So we could do 143 pounds over 1.2 pounds on bottom to 1 kilogram. And we could go through that whole, formal unit conversion to get that answer. But we do this enough that we're going to use a shortcut. And that's simply to take the weight in pounds divided by 2.2. Giving us 65 pounds or 65 kilograms for this patient. And that right there is where we're going to start this calculation. We have a patient that is 65 kilograms. Now we're still calling it a weight. In the medical field, they still refer to it as weight, even though we know that kilograms is actually mass, not weight, but it's being used in the place of weight in the metric system. And we'll start out then with our recommendation. Now notice the recommendation gives us a range, 18 to 20 micrograms per kilogram. We're typically going to start out with the maximum, a larger number of that range. So here I'm going to get rid of the kilograms. I'll put kilograms on bottom. 20 micrograms per kilogram. So the kilograms are gone, but we are now in micrograms. As we look at our other units in the problem, we see that there's not micrograms is nowhere else in the problem. But we do have milligrams there. So it makes sense that we'll get rid of the micrograms and convert it to milligrams. We don't need an equivalency in the problem because this is just a standard conversion. 1 milligram is 1,000 micrograms. So the micrograms cancel out. Next, get rid of the milligrams. We have 25 milligrams in 4 milliliters, so I'll put milligrams on bottom, 25 milligrams on bottom, and the 4 milliliters on top. And the milligrams cancel out, and now we have milliliters. And this being a liquid medication, that's how we will administer it to the patient. We do this calculation. On top, we have 65 times 20 times 1 times 4 milliliters is 5,200 milliliters. On bottom, we have 1 times 1 times 1,000 times 25 is 25,000. And we go ahead and divide this out. 100 divided by 25,000 gives us 0.208 milliliters of fluid that would be administered to that patient for that recommended dose. Now remember, this is the maximum dose. So would like to know the minimum dose. To do that, we're going to use titration. Now the other thing you'll notice is we have ignored this time frame, the hour. We're going to get back to that here when we're done. So to find the minimum, start out with that maximum dose we calculated, the 0.208 milliliters. And we're going to use a ratio. Remember, what goes on bottom is what was used for the 0.208. That's the 20 micrograms per kilogram. And what will go on top is what we want the new number to represent. That's going to be the minimum amount, the 18 micrograms per kilogram. And of course, as always, the units in this ratio should cancel out. So we have 0.208 times 18 divided by 20. Give us 0.187. We'll round it to 0.187 milliliters. So the range, recommended range here, is from 0.187 milliliters per hour. That's where the time frame from a recommendation comes back in, this per hour, to 0.208 milliliters per hour. So there is our range of recommended dosages for that patient, for a patient of that weight. Our order again is to administer the recommended dosage. I'm going to keep writing that in there because it's going to become, there's going to be important information in that as we get into more complex examples. For right now, it's just saying follow the guidelines. So for this example, our recommendation is 8 to 10 milligrams per kilogram per 8 hours. So you'll notice now this time frame has changed. In the last example, that was just per hour. Here it's per 8 hours. And it is important to pay attention to that, even though we kind of, in this problem, will take it out of our calculation until the very end. It's still important to be aware of that time frame. Our label on the bottle, once again, is telling us that we have 18 milligrams in 5 milliliters. And we need to know something about our patient. So this one, the patient is 44 pounds. And we're just going to find our range in milliliters to be administered to the patient. So again, we need to know what's the weight of our patient. So we're going to take the 44 divided by 2.2, 20 kilograms. That's the number we need because this is based in kilograms. So we start with 20 kilograms and we put it over 1. Once again, we're going to use the maximum recommended dose. Here are kilograms, we put kilograms on bottom, 10 milligrams per 1 kilogram. And our kilograms have canceled out. Kilograms go on bottom now to get rid of them. And we have this equivalency, 18 milligrams in 5 milliliters. Kilograms cancel out. On top now we have 20 times 10 times 5. It's 1,000 milliliters. On bottom, 1 times 1 times 18 is just 18. And we divide that out. 1,000 divided by 18 gives us 55.56 milliliters. Now again, that is the max dose. So put 55.56 here. Find the minimum dose. We're going to start out with that max dose of 55.56 milliliters. And we're going to multiply by that again, that titration. We used the 10 milligrams per kilogram. We're going to convert it to 8 milligrams per kilogram. 10 milligrams per kilogram here, that goes on bottom. Converting it to 8 milligrams per kilogram is going to go on top. Kilograms per kilogram cancel out. Now I'm just going to leave my 5.555555 in the calculator times 8 divided by 10, giving me 44.4444 milliliters. Now again, we got to make sure we are aware of our time frame and we include that in our result. That's for 8 hours. So the safe range, the recommended range, 44.44, 5.55, 56 I should round to, milliliters every 8 hours. Now what if the doctor's recommendation has more information and that information doesn't exactly, doctor's order doesn't exactly line up with the recommendation? For example, I have an order to administer the recommended dose every 6 hours. And our recommended dosage might be labeled as 4 to 5 milligrams per kilogram every 8 hours. Notice this time frame here in the recommendation does not line up with the time frame in the doctor's orders. We're going to have to correct for that. Our label, 25 milligrams and 12 milliliters. And our patient, 99 pounds. And again, we are looking for that safe range in milliliters every 6 hours. So once again, we start off by converting our patient's weight in pounds to kilograms, divided by 2.2, which will give us 45 kilograms. So that's where we start our calculation, with 45 kilograms. We're going to get rid of the kilograms. To do that, we're going to use our maximum, the high end of our range of recommended dosages. That is 5 milligrams per 1 kilogram again. Kilograms are gone. Again, we're ignoring this per 8 hours, but we're remembering this that we're going to use it in the end here before we're done. And then we will get from milligrams to liters using this conversion. 25 milligrams goes on bottom to cancel out milligrams. 12 milliliters. So the milligrams are done. On top, we have 45 times 5. 12,700 milliliters. On bottom, 1 times 1 times 25 is just 25. 2,700 divided by 25 is 108 milliliters. Now we have to go back and look at our time frame. This is every 8 hours. So this is what we calculated here is 108 milliliters every 8 hours. Doctor ordered us to administer the medication, though, every 6 hours. So before we administer this, we have to adjust for that difference in time frame. Well, this is also titration. This 108 milliliters is figured off of every 8 hours, and we're going to convert it to every 6 hours. So we see that the hours cancel out. We take our 108 times 6 divided by 8 is 81 milliliters. That is every 8 hours. Now, just like in previous examples, this is our maximum dose. We still need to find the minimum dose. Find that minimum, we take our maximum, 81 milliliters, 8 hours. And we're going to multiply, we're going to do our titration. That was the calculation we have, the 81 was based off of 5 milligrams per kilogram. We want to change it to 4 milligrams per kilogram. 5 milligrams per kilogram goes on bottom. 4 milligrams per kilogram goes on top. And of course the units will cancel out. We have 81 times 4 divided by 5. That's 64.8 milliliters every 8 hours. Notice that these units in the titration always cancel out, and the unit we have at the end is whatever unit we started with here. So this means our recommended range from 64.8, 81 milliliters every, that's not 8 hours, this was titrated to 6 hours, wasn't it? Not 8, this was titrated to 6, so these are all 6 hours here. This was actually 64.8 to 81 milliliters every 6 hours. That's after we adjusted it down to adjust for the doctor's order. I'm going to give you a few minutes and let you try one here. Our order. Administer Recommended dose every 4 hours. Look up the recommendation for that medication is 45 to 50 micrograms per kilogram every 8 hours. Our label here is 12 milligrams and 5 milliliters. We have a patient is 165 pounds. So I'm going to give you a few minutes, about a minute and a half to work through that, and then we will go over that together. So our first step here is to convert our weight in pounds into kilograms. 165 over 2.2 is 75 kilograms. We start off with 75 kilograms, put it over 1, and then we start off again with our maximum range of our recommended dose. So that's going to be 50 micrograms per kilogram. Micrograms over 1 kilogram, and it gets rid of the kilograms. However, we are now in micrograms, and nothing else in our problem is listed in micrograms. So we're going to get rid of the microgram. Using our standard conversion of 1 milligram is 1,000 micrograms. So the micrograms will cancel out. We're now in milligrams, which gives us one more step to get to milliliters. Milligrams on bottom to cancel them out. We have 12 milligrams in 5 milliliters. Let's go ahead and multiply this out. We have 75 times 5 times 1 milligram times 1 times 5 milliliters. 75 times 5 times 5 is 1,875 milliliters. On bottom, we have 1 times 1,000 times 12 is 12,000. And we divide that out. Divide by 12. We get 0.15625 milliliters. And this is for the recommendation, which is every 8 hours. The doctor ordered it to be administered every 4 hours, so we have to perform that titration. We're going from 8 hours to every 4 hours. 0.15625 milliliters. And again, we'll put the 8 hours on bottom because that's what we calculated that off. The recommendation was for every 8 hours. 4 hours on top. That's what we want. The doctor's order wants it to be. So the hours were canceled. Now we just do the 0.15625 times 4 divided by 8. Give us 0.078. We'll round that to. That is milliliters every 4 hours. And again, this is the max dose. So when you find the minimum side, that was found off of the 50. We need to titrate it to the 45. Find our minimum, we take the 0.078 milliliters every 4 hours. That was figured off of 50 micrograms per kilogram. I'll change it to 45 micrograms per kilogram. Once again, these units here in the titration cancel out. Take the 0.078 times 45 divided by 50, and we get 0.07. 0.070 milliliters every 4 hours. So here the recommended range was 0.070 to 0.078 milliliters 4 hours. Rather small dosage, but obviously you can see given in micrograms, it's going to be a small dosage. Our next example takes this to the next level. Our order is going to be to administer recommended dose by IV or through IV. We're going to administer this recommended dose intravenously. Our recommendation is 14 to 15 milligrams per kilogram every 12 hours. Our information on the label of our medication is 25 milligrams and 8 milliliters. And we need a drop factor here. Set up an IV. This has a drop factor of 15 drops per milliliter. First, we need to know something about our patient. This patient is 132 pounds. And what we're looking for is we're looking for a range, our IV setup for drops per minute. So again, we have to convert the weight of our patient from pounds to kilograms. Divide by 2.2, 132 divided by 2.2 is kilograms. Start out with 60 kilograms over 1. And again, we're going to use the maximum and the high end of our range of recommended dosage. Kilograms on bottom so they cancel out. That'll be 15 milligrams per 1 kilogram. Kilograms have canceled out. Next, we get rid of the milligrams. We have 25 milligrams and 8 milliliters, so 25 milligrams on bottom, 8 milliliters on top. The milligrams cancel out. Normally, this is where we'd stop when we had milliliters, but remember now we're going to that next level. We need to turn it into an IV, so drip rate, drop factor. So we have drop factor of 15 drops per milliliters. Milliliter goes on bottom to cancel it out, so it's 1 milliliter. 15 drops, and the milliliters will cancel out. So now we can go ahead and calculate this. On top, we have 60 times 15 times 8 times 15 drops, 108,000 drops over, we got 1 times 25 times 1, divided by 25, is 4,320 drops. Now is where we have to go back to our recommended dose and get the time. Before, all we used the time for was to make sure the time matched up with the doctor's order on how frequently to administer the medication. Here, we need that time to finish our calculation on our flow rate. So this is every 12 hours. So our 4,320 drops is over 12 hours. Take that 4,200 drops over 12 hours. And now we're going to go ahead and turn that into minutes. 1 hour on top, 60 minutes on bottom. Hours are going to cancel. We will have drops per minute here. 4,320 drops times 1 is 4,320 drops. On bottom, 12 times 60 minutes, 720 minutes. So we just have to divide that out. 4,320 divided by 720 is 6. 6 drops per minute. Now we still have to remember that that is the maximum. We have to titrate to find the minimum. Take our maximum of 6 drops per minute. That was calculated using the 15 milligrams per kilogram. And we're going to change it to the minimum, which is 14 milligrams per kilogram. So the milligrams per kilogram once again cancel out. Take 6 times 14 divided by 15 gives us 5.6 drops per minute. Our acceptable range here, excuse me, our recommended range is anywhere from 5.6 to 6.0 drops per minute for that setting. So we can see how this all works with our dosages based on it's going to be similar for dosages based on other patient characteristics. The most common one of those is dosages based on body surface area. The body surface area is literally the surface area of the skin of the body. This type of dosage is used for skin conditions, eczema, psoriasis, stuff like that, and also for medications for burn victims. Again, we're looking at an order, administer the recommended dose. The recommended dose might be 35 to 40 milligrams per, now it's not going to be per kilogram anymore because we're not going based off of weight, it's per meter squared. Body surface area is going to be calculated in meters squared. So 35 to 40 milligrams per meter squared every 12 hours. The label on our supply is going to tell us that that is constituted at 25 milligrams, 4 milliliters. And just like with dosages based on weight, we have to know something about our patient. We don't need to know the patient, we need to know the body surface area. Let's say this patient is a smaller patient, has a body surface area of 0.9 meters squared. So we're just going to start with, and of course we want a range of milliliters to administer to the patient. We're going to start with the 0.9 meters squared. Put it over 1. And now we need to get rid of the meters squared, and we're going to do that by using the high end or our maximum of our range of recommendations. So that's 40 milligrams per meter squared, so 40 milligrams per 1 meter squared. Square meters cancel out. Now to get rid of the milligrams, we have 25 milligrams in 4 milliliters, so 25 milligrams, 4 milliliters. Milligrams cancel out. And we're ready to calculate here. So on top we have 0.9 times 40 times 4. Gives us 144 milliliters. On bottom, 1 times 1 times 25 is 25. And we divide that out. 144 divided by 25 is 5.76. milliliters, and our time frame is every 12 hours. Now we don't need to adjust that time frame because the doctor's orders just said administer the recommended dose, did not tell us a frequency, so we're just going to go off of that recommended frequency of every 12 hours. Still, however, need to find the minimum. Yeah, we start out with that maximum, 5.76 milliliters, 12 hours. Apparently my computer just decided it's time to update. Sorry about that. Well, let's do this. Our homework on the dosage is based on weight. Page 188 through 190, 1 through 21 the odd. I'll put that up in the chat window. Hopefully it pops up on your end for you. Again, if you're just writing that down, it's page 188 through 190, 1 through 21 the odds. And it looks like my computer is going to take several minutes to update, so we will call our session done there for the day, and we will pick up on Friday. You guys have a good day.